Good evening, my friends. My name is Dana Morgenroth. I'm the president of the Pittsburgh Free Thought Community. Welcome to our lecture series. I see quite a few new faces tonight. It's great that you've come out to join us in promoting science, reason, and humanist values in the greater Pittsburgh area. We really need the support these days, so we appreciate it. We've got a great speaker tonight. I'm not going to go through a lot of preliminaries. I'd like to introduce Andy Norman, who is a board member, the leader of the Humanist Initiative at CMU, and soon to be a very well-published author. Andy?
Thanks, Dana. No. Save it for the main act. So it's my pleasure to introduce a very good friend and fellow co-traveler in the ways of philosophy and science. Lee McIntyre is a research associate at the Center for History and Philosophy of Science at Boston University. He's extremely well-read, done some amazing research, and he's published widely. One of his first books was a book called Dark Ages about the case for a science of human behavior. More recently, he's published books called Respecting Truth, Willful Ignorance in the Internet Age. I love that title. And his last book, it's called Post-Truth, has done extremely well, has gotten him attention and speaking invitations all over the world. I'm not allowed to say exactly everywhere he's been invited, because some of it's what's the word? Classified. And he's just come out with a book called The Scientific Attitude, and he's going to talk to us about that tonight. Before I give him the mic, I wanted to tell you about an article of Lee's that appeared in just in June of Newsweek. It's the cover article. It's about flat earthers. Lee actually went, I think we might hear a little bit about that tonight, but he actually went to a flat earth convention and tested out some theories on how do you persuade science deniers. So we'll hear more about that today. I recommend all of Lee's work. It's wonderful, engaging reading. Please join me in welcoming Lee McIntyre.
Okay, yeah, there it is, just like magic. Thank you, Andy. That's very nice. So is the sound level good? Not feedback? Okay. So I'm from Boston, and I'm a research fellow at the Center for Philosophy and History of Science. So I'm a scholar of the philosophy of science, but I decided many years ago, maybe more than a decade ago, that what I really wanted to do was start to write for the general public. I was writing on the topic of the philosophy of science, what makes science distinctive, and it seemed to me that philosophers were sort of failing at this because science was under attack and we had to do something about it. So that's been my journey to get here tonight and to do the writing that I've done. So Andy mentioned that about a year ago I published a book called Post-Truth, in which I argued that we now live in a world where lying is rampant and accountability is often absent. In 2016, the Oxford Dictionaries defined post-truth as, quote, denoting circumstances in which objective facts are less influential in shaping public opinion than appeals to emotion and personal belief, end quote. In its most virulent form, I think that post-truth is the political subordination of reality, where ideology takes precedence over facts, and we're expected to tolerate such nonsense as that a certain recent presidential inauguration was bigger than Obama's, even though there's photographic evidence that says otherwise. That the murder rate is rising, even though FBI Uniform Crime Report statistics say that it's falling. Or that Hurricane Dorian was a threat to Alabama, even though the NOAA and U.S. National Weather Service said that it wasn't. these are ridiculous, they're laughable, but they're also the political subordination of reality. They're trying to make you believe that something is true that's not true. Worse, it's not necessarily meant to persuade you, it's meant to say, I have control. I can say this and there's nothing that you can do. That's the shocking situation of our present political reality, but it didn't come out of nowhere. As I argued in my book, Post-Truth, one of the main roots can be found in 60 years of science denial, from the tobacco industry's 1950s public relations campaign against the link between cigarette smoking and lung cancer. Naomi Oreskes, Eric Conway's wonderful book, Merchants of Doubt, talks about that. To the intelligent design theorist attacks on evolution by natural selection, which I'm sure that everybody in this room is familiar with. To the current outrage of faux skepticism and misunderstanding that's led to just public confusion over the the climate crisis. Clearly, we need a better way to fight back, not only against the metastasis of post-truth, but also against the science denial that I think led to it. In doing so, I wonder whether we could look to scientists for help. And here I'm going to say not necessarily. And I know there's some scientists in the room, and I want to say I don't mean that with disrespect. I believe that science is wonderful and that scientists as a whole are exemplars of what it means to defend the idea that facts matter in the search for truth. It's just that in graduate school, scientists are taught to become expert researchers, but almost none are trained in effective public communication. Likewise, scientists are rarely trained in the logical or methodological roots of their disciplines. And some may subscribe to a view that philosophers would call naive realism, which is to hold simply that science discovers truth. When called on to defend their results, therefore, some scientists may be tempted to present their findings as fact and then seem shocked when an audience of doubters don't believe them. But here's the problem. You don't convince somebody who doesn't believe in evidence by presenting them with more evidence. You do it, if at all, by helping them to improve their reasoning. Enter the philosophy of science. For the last 100 years, the philosophy of science has been engaged in a furious debate over what's distinctive about science. They spent a lot of time talking about method and trying to come up with some sort of logical criteria by which we could separate science from non-science to settle once and for all why scientific theories have this special claim to believability that I think they do. But largely we've failed. Even on its own terms, most philosophers of science now admit that this demarcation problem probably can't be solved. As a consequence, philosophy's not done much to contribute to the defense of science. And that pains me because most philosophers of science, that's why they're in it. They believe in science and they want to defend science. This has led some scientists to come to the conclusion that philosophy of science isn't really very useful to them. As the Nobel Prize-winning physicist Richard Feynman memorably said, philosophy of science is about as useful to scientists as ornithology is to birds. There's enough sting in that remark to make it hurt, but perhaps we've just been going about it wrong. Science is currently under attack, and I don't think that now is the time to refuse help from your allies. So I hope that scientists are willing to accept help from the philosophers of science. And I don't think it's the time also to whistle past the graveyard or to pretend, well, it's all going well, except for those science deniers who don't believe us. That's the problem. They don't believe us, and they're getting to be more and more of them, and they have influence over our government and the consequences that all of us will suffer for that. So part of the blame, if blame is the right word, is with the philosophy of science. Part of the blame is with scientists. Part of the blame is just for all of us to learn how to engage better on these questions. I think that scientists are often too quick to get exasperated and say, this person isn't worth talking to, and refuse to engage in debate when someone questions their evidence. Now, perhaps it's understandable that someone who's devoted their entire career to the power of experiment and facts would grow impatient with those people who would thoughtlessly question their data or accuse them of lying or fraud or not knowing what they're talking about, etc. But another part of the problem, I think, is that scientists' own conception of what they're doing, or at least what they say they're doing, occasionally gives aid and comfort to some of the most prevalent myths that are held by science deniers. For instance, that a scientist's job is to prove a result, that we have to be certain of a finding before we're justified in believing it, that anything less is just a theory. Science deniers use those kind of myths to shore up their conclusion that until the day comes when scientists reach absolute certainty, any hypothesis is as good as any other and they might be justified. Except that day's never going to come, and every scientist knows it. Every scientist understands probability, uncertainty, statistics. They know that they're not in the business of proving things or finding certainty. So why then do scientists sometimes lie when confronted with a room full of doubters and pretend that their results have been proven? Why do they say that vaccinations carry no risk or that their models of climate change have been conclusively verified? The problem, I think, is that most scientists don't know how to admit such things and still offer a robust defense of science. They're afraid they'll get nailed to the wall by these deniers the minute you let any uncertainty show. But what if they did know how to defend science better? What if the defense of science could be more honest and based on the idea that openness and uncertainty is a strength instead of a weakness of science? That of course we don't know everything, but that's what makes it rational to, but this doesn't make it rational to question the well-corroborated findings of science. Science is intrinsically fallible. That's part of what makes it so special. As opposed to deductive logic, where certainty can be reached based on the validity of its form, when you're dealing with an empirical subject, there's always the possibility that your theory might be proven wrong by future data. That's just how inductive reasoning works. Scientists always have to allow for the possibility that their conclusions are going to be overturned. In science, you're required to balance openness to new hypotheses with a reflex to doubt any new idea until it's been thoroughly tested. Carl Sagan talks about this, and it's a beautiful thing to be both open-minded and skeptical at the same time. This is what allows us to learn from experience. Science never shuts the books, but it's also why no matter how good the evidence is, we will never be able to show that vaccines are 100% safe. We'll never be able to show that electrons are real or that smoking causes cancer. Those are all things that we believe based on good grounds. But we can't prove it, and we don't need to prove it in order to fend off the science deniers. Those of you who have studied philosophy already know about the problem of induction, which says that anytime you move from a pattern in an area that you do know and try to project it into some area that you haven't yet experienced, it may not work. For logical reasons, there's just no way that you can get science to offer deductive certainty. This problem has flummoxed philosophers of science for the last 2 centuries. And despite many attempts, no one has ever found a way to resolve it. But this does not mean that science has no solid basis. Even if science is based on inductive reasoning and its claims can never be 100% proven, this does not mean that any belief is as good as any other, nor that there's no such thing as likelihood given the evidence. It's just that perhaps the basis for what's distinctive about science is not rooted in the logic of its method, but instead in the attitude that scientists use to approach their explorations. Although that doesn't solve the problem of demarcation, and I don't want to pretend that I'm trying to do that, it does allow, I think, for one of the most powerful ways that we can defend the unique authority of science. So what I'm trying to do is to give scientists a better way to talk about what they do so that they can push back against science deniers. Because I don't want Feynman to criticize me about the ornithology thing. It's sometimes held to be anathema to the philosophy of science to talk about values rather than facts. But that's precisely what I'm going to do next. Because I think that in the end, it's the norms and attitudes of science that make it special. I call my thesis here simply The Scientific Attitude, and that's what the book's called. And it has two parts. Now, this is oversimplifying, so you still need to buy the book to understand it. The scientific attitude goes like this. First, scientists care about evidence. Second, they're open to using this evidence to change their beliefs. It's the second part that's really crucial, because that's what allows scientists to distinguish themselves from science deniers or pseudoscientists. With climate change deniers or anti-evolutionists or anti-vaxxers, their beliefs are not customarily based on evidence, but on ideology. If they use evidence at all, they do so only selectively, normally to support their beliefs rather than to test them, confirmation bias. Instead of changing their minds, they look for ways to show that they're right. But that is not what scientists do. It's not that scientists are perfect or never make mistakes. They suffer from the same cognitive biases as the rest of us. And in individual cases, of course scientists want their theories to be right. Tenure, grant money, of course. But here's the thing. In science, we don't let them get away with that. We don't just take their word that their theory is true. Their colleagues check up on them. It's competitive. The scientific attitude is judged not just by how individual scientists feel about their work or what they want to be true, but rather on the basis of a shared ethos of critical scrutiny and empirical testing that's reflected in the community practices of science, peer review, uncertainty. It's just that they've developed a wonderful system of checks and procedures to help them deal with this doubt and uncertainty in a rational manner. In my book, The Scientific Attitude, I explore one of my favorite examples of this, which I'll share with you now. It's a story of Ignaz Semmelweis, who was a lowly assistant physician in Vienna in the 1840s, and he's the one who discovered the cause of childbed fever. Childbed fever is a potentially fatal infection in pregnant women that we now know is caused by germs, but germs weren't discovered until the 1850s. So Semmelweis worked at the Vienna General Hospital, where pregnant women were separated into two wards. In Ward 1, that was attended by medical students, there was a 29% mortality rate. Just imagine that. Whereas in the adjacent Ward 2, that was attended by midwives, it was only 3%. What was the difference? Semmelweis tried various hypotheses. He tried the position of delivery, the physical layout of the ward. They even tried this, that every time a woman died in Ward 1, they sent a priest to do last rites, and the priest, in walking in, rang a bell. And the hypothesis was that ringing the bell probably might have scared people to death, literally. So Semmelweis said, stop ringing the friggin' bell and walk around the other way. But of course, the mortality rate didn't change, and we know why, but he didn't. Finally, Semmelweis hit on a key difference. The medical students came to Ward 1 directly from performing autopsies. And back in those days, no one washed their hands because they didn't know about germs. Ew. Semmelweis instituted a program of hand washing in chlorinated water, and the mortality rate fell. He hypothesized that childbed fever was due to the presence of putrid matter, that's the nice word, on the medical students' hands, which was largely correct, even though they didn't know why yet. But he knew the how, he didn't know the why. Of course, his ideas were resisted. This is the incredible part. He was fired, committed to an asylum, jailed, and beaten to death by the guards. That is to say, the guards beat him so badly that he bled, and he died of a blood infection similar to childbed fever. Later, of course, he was vindicated, as martyrs tend to be. But like so many other martyrs for science, his legacy lived on as a demonstration of the power of changing one's beliefs based on evidence, which is the essence of the scientific attitude. Now compare this to the strategy that's employed by pseudoscientists who, despite their protests that they're skeptics, they're really quite gullible. And they embrace conspiracy theories for which they really don't have any good evidence. There's a double standard of evidence usually amongst that community. Compare it to science deniers who profess to care about evidence, then cherry pick only those pieces of evidence that suit what they already want to believe. Talk to your favorite vaccine denier, and it isn't too long before they'll talk about the governmental cover-up, which shows that the CDC paid off the Institute of Medicine to suppress the data on thimerosal. Ridiculous. Or they'll tell you about a single study, though it's long ago debunked and proven to be fraudulent, which allegedly showed that vaccines cause autism. That study is so bad that it's now actually been shown to be fraud, but you still hear it bandied about. It's not that science deniers have never been exposed to good evidence. It's that they have no good normative context for knowing how to reason on the basis of evidence. And then it occurred to me how to use all this to fight back against science denial, and I got very excited. If you look back at history, you realize that most human belief is based not on evidence, but on social identity. Even in the present day, people seem much more prone to change their minds based on an interaction with someone that they trust rather than on data. As we know from the work of Daniel Kahneman and others, he wrote that wonderful book, Thinking Fast and Slow, there are numerous cognitive biases that have been wired into human brains for millennia. This makes it all the more remarkable that relatively recently in human history, people like Semmelweis and Galileo and Giordano Bruno came along to champion the idea that evidence matters because it can be used to push us toward the discovery of truths that we'd miss if we just believed our ideology or our orthodoxy. Now today, and especially in this room, we think of that as very wise and obvious. But for most of human history, our beliefs have been based on what others in our community thought, on authority, on our peer group, and what we ourselves wanted to believe. And indeed, for many people, that's the way it still works today, which is why it shouldn't be surprising that there are so many science deniers. There's been an enormous erosion of trust in recent years due to the exacerbation of cognitive bias by social media and political partisanship that's undermined our willingness to believe in experts. There's another book on this called The Death of Expertise by Tom Nichols. But people seem flummoxed in this post-truth era by a very simple question. It was the subject of magazines in the New Yorker and the Atlantic. Why are people not convinced by facts right in front of their face? And we seem flummoxed by this. But the answer is not merely that they're irrational, though they may well be. It's that most people's beliefs aren't revisable by evidence because they were not based on evidence in the first place. For many people, belief isn't about evidence. It's about the extent to which a belief fits with something that they already care about. Ideology comes first, reality comes second. Some scientific beliefs threaten a person's identity. Some don't. This is why even science deniers, I call them cafeteria skeptics. They will pick and choose. Yes, they'll believe in chemotherapy, but no, they don't believe in vaccines. Yes, they'll drink pasteurized milk, but they won't touch a GMO. But that's a bastardization of the process by which justified beliefs are formed. Looked at in this way, you can more readily appreciate the enormity of our task because there really aren't any magic words that you can say to a science denier to convince them. There is no definitive experiment. There are no facts that you can share that they'll say, look how stupid I was. Their beliefs are based on what makes them feel part of the community and enjoy a sense of belonging. And that community may no longer include scientists, especially if we don't talk to them. Even empirical beliefs can be tribal. At some level, people would rather believe a lie told to them by someone that they trust, who's in their group, than a truth that's told to them by an outsider. When people say that climate change isn't real or that vaccines are dangerous or that the earth is flat, they're not just telling you about their beliefs, they're telling you about their values and who they trust. Science denial undermines not just the findings of science, but also the process by which credible, well-justified empirical beliefs are formed in the first place. And I think that we need to talk more about that. Scientists need to share not just the findings of science, but how science works, the rigor with which they've worked, and what probability actually means. But it's always been like this. Science is the exception, really, if you look at human history. We think that science deniers are the weird ones, but really, looked at from an historical perspective, it's science that's the newcomer. It's an awesome thing. Just think for a minute. It's an awesome thing to have your mind changed by evidence. To have the courage to say, I want to believe that X is true, but the evidence is telling me that X isn't true, therefore I won't believe it. That is an incredible thing that we do. But as I've said, cognitive bias is just as wired into scientists' brains as into anyone else. So how did they overcome it? I think through the scientific attitude. It's an amazing thing that in science there are a set of values that have helped us to overcome these very human, wired-in tendencies. And perhaps that's what allows scientists to embrace a very different identity than the layperson, that of the true skeptic. All of these community-wide procedures, the ethos of science that allows them to be very competitive, to question one another. You know, the highest thing is to maybe invent your own theory, but the second is to show a flaw in somebody else's. They do this through peer review, through finding flaws. So what can be done by those of us who care about science? We have to teach science deniers, I think, a different set of values, not just a different set of facts. We have to help them abandon the myth of certainty in science and explain the important role that evidence has in building warrant for well-justified empirical beliefs. When certainty is the standard, it's easy for deniers to call themselves skeptics and to pretend that they're justified in holding out for truth. You've heard climate change deniers say, well, you can't prove it, I'll wait till all of the evidence are in. Well, that day's never going to come. But it allows them to feel virtuous. Instead, we have to show them what true skepticism actually means. We have to show them that the scientific attitude is the direct opposite of the mindset that leads to post-truth. Now, what would this look like in practice? Well, it's funny you should ask. In November 2018, as Andy said, I went to the Flat Earth Conference in Denver, Colorado. I didn't go as a scientist, I went as a philosopher. If I pulled a gyroscope out of my pocket or I tried to rig up a Foucault's pendulum, they just laugh at me. And I also thought that if the flat earthers hadn't been convinced by evidence that had been around since Aristarchus 2,300 years ago, they probably weren't going to believe me. Instead, I sought to talk to them about their reasoning strategy. The flat earthers I met professed that their beliefs were based on evidence. Now, even though a good deal of them were fundamentalist Christians, and they did maintain that their beliefs were not faith-based. They maintained that they had evidence both that their views were correct and that mine were wrong. They talked constantly of doing their own experiments. Yet virtually all of them were conspiracy theorists who believed that NASA had faked the moon landing, that Antarctica wasn't a continent, but was instead spread out as a mountain range around the circumference of the Earth. That's, by the way, what keeps the water from falling off because, they believe that all government leaders, including Trump, were in on the attempt to cover up the truth of flat Earth, and that the rest of us had all been brainwashed into being what they call globalists, or the unkind word is globetards, in school. That's the language that was used. I apologize. Most of them believed in a host of other conspiracy theories too. But I sought to engage them in a common, respectful manner, while remaining adamant in my conviction that their beliefs were not only false, but that they were irrationally conceived. That was my point. For the most part, I just let them talk. It's amazing when you let somebody talk how they will contradict themselves. But then I asked a pertinent, razor-sharp question from the philosophy of science, which is not mine, it's Karl Popper's. Instead of asking them, well, what evidence do you have that your beliefs are true? Because, they had that. It wasn't good evidence, but they thought that they had it. I asked them this, what evidence would it take to convince you that you were wrong? They didn't like that question. They couldn't answer that question. I got a lot of mileage in Newsweek out of that question. It seemed like one they'd never heard before. At the end of one of the main scientific talks, I approached the speaker, who'd made a big deal of the fact that although he had no university credentials, he was wearing a white lab coat. And I pulled him aside to ask him a few questions. During his talk, he'd presented a photograph of the skyline of the city of Chicago from 60 miles out in Lake Michigan. The trouble was, at that distance, the curvature of the Earth should have made even the Sears Tower disappear below the horizon. So he thought he had his proof. Now I pushed him on this. I said, how do you know the photo isn't fake? And he said, well, I know the guy who took it. And I went out myself about a year later and I saw the same thing. Now, during his presentation, this scientist had suggested all sorts of conspiracy theories about how virtually all of the photographs from NASA had been faked, that none of them could be trusted. But he trusted this photo, right? I pointed that out to him. Now, as it turned out, this photo was a legitimate photo. It was actually, if you, on some nights under certain conditions, which I'll now talk about, you can go out and actually see the skyline of the city of Chicago and take a picture of it. It's an optical illusion, but you can photograph it. I shared with him a quick calculation I'd done based on the numbers he'd provided during his talk, showing that you really only had to go out 45 miles for Chicago to disappear. That he wasn't an incompetent mathematician. He said that he'd gone out 46. But the picture was from 60, so it should have been gone. He scoffed at any suggestion that the whole thing could be explained by what's actually the case. It's something called the superior mirage effect. Light doesn't necessarily travel in a straight line. When you've got the surface of the water is extremely cold, the surface of the air is hot, they come together, it bends the light. So what you're actually seeing is the superposition of the city of Chicago. You're seeing an image of the city of Chicago. You've maybe never seen that. What you have seen is when you're driving on hot pavement, you'll see it looks like there's a puddle of water. That's the inferior mirage effect because the pavement is hotter than the air, so it's the inferior mirage effect. When the surface of the water is cooler than the air, then it's the superior mirage effect. Well, I shared this with him, and he talked about it, in fact, during his talk, and he had said that he laughed. He said, I dealt with that in my talk, it's made up. And I said, you didn't deal with it in your talk, you just said you didn't believe it. And he said, well, I don't. Okay. He started to get a little antsy and began to greet his fans, because you understand I grabbed him just after he came off the stage and he was wearing his white lab coat and there were a bunch of admirers there. But I, like Columbo, I just had one more question. I said, why didn't you go out 100 miles? And he said, what? And I said, 100 miles. You went out 46 miles and you saw the city of Chicago. And you said that the superior mirage effect couldn't be it. But if you'd gone out 100 miles, not only would the city of Chicago disappeared, but also the superior mirage of the city of Chicago would have disappeared. So why didn't you do that? If you did, you'd have your proof. He shook his head and said, we couldn't get the captain of the boat to go out that far. Okay, now it was my turn to scoff. I said, you devoted your entire life to flat Earth and you couldn't pay the captain to go out an extra 55 miles to have the definitive experiment to shut people like me up. And he turned away and he began to talk to someone else. But I got my revenge because I wrote about it in Newsweek. Of necessity, this is going to be a slow process. Science denial didn't take hold overnight, and we can't vanquish it overnight either. But I'm convinced that the best way to do it is not to try to ram evidence down somebody's throat, and it's not to insult them, but to teach them the values of science. And we do that best by trying to embody those values, by listening to science deniers and taking on their points one by one, by engaging them rather than walking away. I may not have convinced the scientists that day at the Flat Earth Convention, though I trust that some of the others standing nearby might have heard me and thought, I'm going to Google that later and see what that is, superior mirage effect. And maybe just by showing up, I began to build some trust. And I'm going back in a few months, and we'll see. At least I showed up. I took on the worst form of science denial that I could imagine, and I didn't let them get away with lazy thinking unchallenged. I went to the Flat Earth Convention because I wanted to face science denial in its most virulent form. My working hypothesis was and is that all science deniers use basically the same reasoning strategy. Start with ideology that you're committed to no matter what. Cherry pick evidence in its favor. Exploit uncertainty where you can. Try to discredit those who disagree with you and cast doubt on their objectivity. Cite your own experts, even if they're not experts, claim that you're actually being more scientific than the scientists, and then throw in a little conspiracy theory, and you're done. Climate change denial, anti-vax, anti-evolution, I think they all follow this pattern, which, by the way, means that if you can figure out how to talk to one of them, you can talk to all of them. And that's what I try to do at Flat Earth, to work on a strategy, to work on a script that I can then use. The Flat Earthers aren't really hurting anybody, but the climate change deniers are, and I wanted to figure out how to talk to them. That's what I'm working on now. I'm going out and doing road trips to talk with science deniers, and my next book is going to be called How to Talk to a Science Denier. That's it.